Hello, this is a quick walkthrough of the testing framework that we use to get the graphs and such for the paper. I'll start by pointing a little bit at the hardware here on the table. This board right here is what we're testing right now, and it's an NRF 52840 DK development kit. We're going to flash a program onto there which is the button blinky program written in SenseVM, and that program listens for a button press and like mirrors an LED to the state of the button. So if the button is down, the LED is on, and if the button is up, the LED is off. And for testing purposes, we are interested in seeing how long does it take between the button going down and the LED turning on. So again, for testing purposes, this is connected with these two wires to another board, and this blue wire here will be the button. So we will set a 1 on here for the button down and the 0 otherwise, and the green wire will represent the LED. And instead of actually connecting those wires to a button and an LED, we have connected them to another board here, which is an STM32 based board that runs a little firmware which performs experiments against the system under test. So it will press the button 1,000 times and each time measure how long does it take for the response. And the actual measurements taking place inside of the STM32 is done using an 84 MHz timer, which means we get something around an 11 nanosecond resolution of the time there. We also hook it up to the oscilloscope. So we have one line here on the oscilloscope for the button and one for the LED. So we can take some control measurements using the oscilloscope and see if what we see on the automated testing here makes sense. So let's turn to the software side. Now, if we go into the NRF 52840 overlay file, we make use of these overlay files that Zephyr uses to configure the target device. And normally a button would be connected to something that's an actual button on the board, but for these testing purposes, then we have these made up: one LED which we call LED 100 and one button which is button 100, and those are just aliases or names for a specific GPIO port on pin on the board. So for this experiment, when we're taking measurements, what we call the button 0 is this made up button 100, and what we call LED 0 is this made up LED 100. So that we make use of these overlay files to actually configure the SenseVM system, the runtime system, its connections to I/O when using Zephyr as the underlying operating system. So let's flash this on here. Let's flash. And then, so here we have a GUI for the automated scripting that the STM32 does. And when we click start here, it will perform 100 tests against the system under test. And you can see that there's stuff going on here on the oscilloscope as well. We'll rerun this in a moment and then put it in a triggered mode, and then we can compare single. Okay, so if we restart the test, the oscilloscope captures the first situation, and now you have two lines here, a blue and a yellow one, and we can see that there's a rising edge on the blue one on the yellow, and that the blue one represents the button and the yellow one the LED. So let's see how far apart they are roughly. There, 82, and it seems to correspond fairly well with the results we got, and we also can see that it was quite consistent. We got the same result on all 1,000 samples. That's all I was planning to show. Thank you very much.